All right, ladies and gentlemen, here we go. Rational expressions. Now, an expression would be something like this. X plus 2. It's not an equation because there are no equal signs. Very good. So if I take this expression and I take another expression and I put it on top, there we go. Now we have a rational expression. A rational expression is an expression that's in a ratio. Did we make a ratio something to something else? And so I have two expressions that are in a ratio. So these are rational expressions. Now, the thing about it is, these rational expressions I could graph what value is excluded, what can X not be. Okay, I disagree with -2 because again, can I have 0 on top? Yes, but can I have 0 on bottom? So X equals -3 is not allowed. Okay, if I were to graph it, I would have a vertical asymptote at -3, and my horizontal asymptote would be at 0. Okay, actually, technically, my horizontal asymptote would be at 1 in this case, but that's for a whole different set of reasons. Okay, so you have something like this. Now, can I reduce this any further? Can I make that any more simple? No. Now I want to know what's the domain of this function. Now the domain is all the possible x values, correct? So if it's all the possible x values, then I could say it's going to be any x I want from -infinity to +infinity. So that'd be all real numbers. Remember, the big R means all real numbers as long as x does not equal -3. So that's the first thing. Now, we talked about in our last section, whereas what if I have something like this, x plus 1 over x squared minus 1? Well, what do I need to do to the bottom? What do I need to do to the bottom? I have x squared. Break up the x's. How do I break up an x squared minus 1? What do I put where and where? X and x. Plus and minus, 1 and 1. Does anybody notice anything before I go on? Take a look, folks. Normally we'd say, hey, x can't equal 1. X can't equal -1. But what do you notice about this piece and this piece? Cancel them out. Now I'm simplified, left with this. So what's the only number x can't be? +1. We eliminated one of our problems, didn't we? Now let's go over here. What if I have 6a over a squared plus 2a? In this case, what can't a be? A cannot equal. Well, let's do what with the bottom? Break it up. What do I do first? Nope. What do I always try to do first, folks? Take out common. A plus 2. So what can't a be? Can't be -2, because -2 would make. What about if this a? What can't that a be? 0, because if I put 0 in here, would that be divided by 0? But again, let's pause before we make a final answer. What do you notice is in the top and the bottom? So what can I do? So now that leaves me 6 over a plus 2. What's the only thing a can't be? -2. Okay, thank you. All right, let's do a harder problem. Let's go 4x minus 24 over x squared plus, not plus, well, plus fine, -12x plus 36. It is. In this case, what should I do to the top? I can take out a what? 4, leaving x minus 6. What can I do to the bottom? I try taking out common. There's nothing common, so I break it up. X and x, minus 6 and minus 6. What can I do now to simplify?
You can take out x minus 6.
leaving 4 over x minus 6. What can't x be?
6.
Positive 6. That's it. All right.
Question.
Yes.
Would we ever include a plus or minus sign in this chapter?
No.
Okay.
All right. So let's do one other type of problem. Let's go up here. Say 15x to the 4th y squared over 40x cubed y cubed. Now, we've done problems like this before. What do I need to do to reduce? What can I get rid of? X's. How many do I have in the top?
4,
How many in the bottom?
3,
So if I cancel 3 out of here and 3 out of here, what am I left with?
4, 15.
1x on the top. What about y's? I got 2 in the top, 3 in the bottom. What am I left with? 1y in the bottom. What about 15 and 40?
Take out 5.
Divide both by 5 and I get 3 over 8. Is that as simple as it gets?
Yeah.
What can't y be? 0. Y cannot be 0. All right. So that's what I want you to take a look at.
Nap time? Eat burritos.